Thank you, Zoom.
Good evening, Law.
Guys. Maybe need open. Wait. मैंने देख है ना उधर से कहीं और so we are here, right? Security. Come on, Law. You have to be. Under your attention. I think so. Yeah, right. Just give me 1 minute. Let me check. The topic name is a villain hopping. I know it's not showing over there. So this is the attack, right? That is called as a switch spoofing attack. We have seen this part, right? This is also known as a DTP attack. Okay, this is also known as a DTP attack that we have already seen, right? Switch port motor access and make that trunk interface as a no negotiate, right? So we have this is the DTP attack, also called as a switch spoofing attack. Depend on the book, they are giving the different names. So if somebody will ask you what is DTP attack or switch spoofing attack, both have the same answer. As called as VLAN hopping attack. This is the understand this topology right now. Okay, I'll do one thing better to put in the because I cannot draw one. It's totally so already everything is good. This topology is very good actually. So no need to draw, everything is there. Now, this is the DHCP server. Okay. And everyone knows, and we knows that what is the use of DHCP server, right? We know the use of DHCP server. This is the one client over there, not client. This is attacker actually, or the DHCP server is present on VLAN number 20. DHCP server is present on VLAN number 20, and this attacker is present in the VLAN number 10. And this VLAN number 10 is a native VLAN, right? And as we know that native VLAN does not perform. This is the things and as we know that, right? And trunk, what trunk is going to trunk add the tag and remove the tag. This is the use of trunk interface, right? Now try to understand one thing. What happened if you see one thing? This attacker is belong to the VLAN number 10, okay? And he's sending the one data that's a payload hour. The payload is what? It's a like a one kind of virus that he's sending into the VLAN number 20, and is targeting to whom? DHCP server, right? So attacker is sending the packet, right? And what he is doing actually over there, he's put the VLAN number 10, right? That's a normal VLAN number 10 is will be there. And after that, what happened? He'll put the virus over there. There's no payload. Payload is nothing or is a data. And he sent this packet to the switch 8, right? Double tag packet. Why I'm calling this guy a double tag packet? Because we have two VLAN information over there. two VLAN, VLAN number 10 and 20. The reason is have a VLAN number 10 because I'm belongs to the VLAN number 10 over there, and I'm targeting to the VLAN number 20. So I'm putting the 20 over there, right? When a switch will receive the data, right? When switch A is ready to forward the packet onto the trunk interface, the first stack is stripped because it is the same as a trunk native VLAN. So what this switch will do on this trunk interface, right? They will remove the VLAN number 10 tag, right? Because the VLAN number tag is also belong to the native VLAN. Once the switch B will receive this packet, what switch will receive? See, the packet is received by the switch B. As the second tag is a strip VLAN number 20, it appears to identify the source VLAN as a VLAN number 20. So what it will do over there? It will send the packet to whom? DHCP server. And what DHCP server is receiving actually? The guys receiving only the payload. So now this actual packet, right, is coming from the VLAN number 10, is sent to the VLAN number 20. That is not normally possible, right? Without inter VLAN routing, it's not possible. And without manipulating the native VLAN concept, it's not possible. But it is happened, just attacker is doing the attack over there. Because attacker just uses some kind of software and they will put the some another VLAN information over there. And they can easily do the attack. So in this case, what happened? Now DHCP server will be down. Of course, this is the virus, right? In the payload virus is there. So what happened? It's trying to down the DHCP server. So whatever the user is setting, all the user will not receive any kind of IP address from the DHCP server. It can be any server, right? It can be any server. It can be any server. Now tell me one thing, guys. Will the PC can communicate with another PC? No, they cannot communicate. The reason is not able to communicate because the DHCP server is not possible. So once your IP address will get expired, this trying to reach to the DHCP server, but DHCP server is not present. And this is just happen. This is just happen because of native VLAN does not perform the tag. This attack is just happened because of native VLAN does not perform the tag. So the solution is what? Solution is very simple. You need to go on the switch side and tell the switches, hey, you have to perform the tag for the native VLAN. Simple time. Simple command. You just need to go on the switch interface, sorry, switch side, and need to tell this guy, hey, I need to perform the tagging for the native VLAN as well as, and now it will work fine. And if you don't want to do this thing, then another thing is what? You just need to create the one bogus VLAN, any VLAN, right? As the VLAN number 999. And what I'm going to do over there, I'm going to make this guy as a native VLAN, right? And from the trunk interface, I'm going to remove the 999. And for the better security, whatever the interface are present, whatever the interface are present, I'm going to put that interface in the shutdown mode. So in that case, also what happened? There's no kind of attack is happening. First, I need to get the native bogus VLAN. I'm going to make this guy as part of the native VLAN, right? And I'm going to remove the native VLAN from the trunk interface. So in this way, you can prevent the attack as well. So this is the two ways that you can do. All good? Anyone has a questions? So this is the way that you can prevent the attack in your network by using the VLAN hopping attack. So recommendation, you can use anyone. Either you can use this one or either you can go for the knitting. It's up to you guys. All good? Now, let's come back to the spanning tree now. Spanning tree protocol. Guys, I'll let you know first thing before I'm going to start your spanning tree protocol concept. I first let you know what is loop and types of loop. These two things are very, very important to get the understanding of the spanning tree protocol. Because if you don't know what is loop and types of loop, then what is the need of a spanning tree protocol? What is the meaning of loop? Loop means what? For example, this guy has started their journey from A location, right? This guy has started their journey from A location, like, and after some time, what happened? After 5 to 6 hours, they came back to the same location. That is called as a loop. He has started the journey from the A location, and after the some hours, 5 to 6 hours, they came back to the same location, right? That is called as a loop. In this case, what you are wasting over there? You are wasting your time. You are wasting your resources. Of course, you are going to drive the car or maybe the bike, right? Anything. So your petrol will be wasted over there, right? In normal life, the peoples are, yeah, used to the loop as well as, right? Because for example, if you go some new location, right, 100% you're going to make a loop. For example, if you for me last time it was happened, I was went to the UT, right? I moved to the same location after the, after the 1 hour, because I was going to try to go somewhere else. I moved to the same location. So the loop is not a big deal. It happened. In networking as well as your packet being looped. And in networking, if I categorize the loop, we have a two types of loop. Either we can have a layer 2 loop or either we can have a layer 3 loop. The layer 2 loop, I'm talking about the frame part, and layer 3 loop, I'm going to talk about the packet, IP packet. So if you have a look in the layer 3, first of all, oh, sorry. Understand this part. Here you will get a, here you will get clear the concept of TTL field. All done. And here we have, guys, just pay attention. This is the layer 3 loop, and here you will get the clear the all the concept of TTL as plus. Now, can you see one thing? This diagram topology, we have router number 1, we have router number 2, and we have a 2.0.0.0 address, right? And we have a 1.0.0 address in the downside. So we have 101 link over there. This IP address of this particular link, 102 of this particular link, 2.1 of this particular link, and 2.2 is this particular link, right? All good. We have a one static route from the router number 1, right? And we have a one static route from the router number 2. And if you have a look the next hop information, right? Okay, this should be not there. It should be 1 or 2 this side, and this should be that's correct, right? Yeah, 2 or 1. If you see one thing over there, both sides have a default dot, but the pointing is what 1 or 2 from this side R1, and pointing is what 2.1. So in the routing table of R1, we have something called this information. In the routing table of R2, we have something called this information. When R1 will, and this route is not exist anywhere. This 8.8.8 is not exist anywhere. If I say the ping 8.8.8.8.8, what happened from the router number 1? According to the router number 1, routing table said, hey, 8.8.8.8, I need to use 1 or 2, right? And I will perform the recursive lookup, and I will find my source IP address will be 1 or 1. So this packet will be R1 will create, right? 1 or 1 source, destination will be 8.8. Oh, fuck. Bitto, कुत्ता आ गया. Oh shit, man. बिट्टू भगा. तुम बंद करो यार, गेट बंद करो. गेट बंद करो. हट गया मेरा. Okay, so if you see the source IP address is 101, destination IP at 8.8.8, right? Try to understand this, guys. One thing over there. What happened? R1 will forward the packet to whom? R2, right? R1 will forward the packet to whom? R2. And what will be the TTL field over there? 255. What R2 will do over there? R2 will receive this packet, and according to the R2 routing table, 8.8.8.8, according to my routing table, if any packet is coming for the 8.8.8, I need to forward the packet to whom? 2.1, right? Now the same packet is coming over there, from R1 to R2, and R2 will forward the packet to whom? R1. R1 will receive the packet. It will look up the routing table. According to my routing table, 8.8.8, I need to forward the packet to whom? 1 or 2. R2 will receive the packet. According to the R2 routing table, any packet coming for this network, 2.1. R1 will receive this packet. According to my routing table, 1 or 2. And according to my routing table, 2.1. This packet will be continuously moving. Once the packet TTL, if you see that from here to here, right? Every time, once the packet will move from one hop to the another hop, once this packet will move from one hop to the another hop, from here to here, sorry, from here to here, it will decrement the 1 TTL. From here to here, it will decrement the 1 TTL. Here to here, decrement the 1 TTL, decrement the 1 TTL, decrement the 1 TTL, decrement the 1 TTL, and decrement the 1 TTL. Right? Once your TTL will become a 0, your packet will be dropped. So on a layer 3, guys, on a layer 3 network, something called we have a TTL field that is called as a time to live. And this guy is used to prevent the loop. You see the name of this guy, time to live. And this loop, I'll tell you one thing, this loop is of finite. Finite means what? It is starting from the 255, and once it will reach to the 0, what happened? Automatically the packet will be dropped. So we can say that this is the loop is a finite loop, right? At the finite time, this loop will be there in the network. At the finite time, this loop will be there in the network. If you have a look, R1. Okay, I think so. I have a pre-configured IP addresses. Yep. Do so IP route. Yep. R2. So IP interface brief. Yep. So IP route. I don't know. All done. And now if you have a look, I'll generate the packet from here, ping 8.8.8. Before I'm going to generate the packet, let me capture this link so that I can show you the TTL field as well as. Hit enter. Can you see that TTL is decremented? And now your packet is time to live exit. Have a look. On an IP header, source IP address 101, destination 8.8, TTL is 255, the protocol number is ICMP1, right? And this TTL is decrementing at every hop. Why they're saying the 253 right now? It has to be so the 254 because I'm capturing the one link, right? Another link have a 254 over there. And now if you go downside, see, once your TTL will become the one, after it will become the zero, right? What happened? Time to leave exceed, right? Zero means what? I need to drop the packet. Do we have any other packet over there? It's a time to leave exit packet because this packet has downtime. There's no sense of for this packet because the TTL will now become the zero, right? This is the last TTL one. So on the layer 3 network, guys, on the layer 3 network, we have a TTL field that is used to prevent the loop. And this loop will be just a finite. We have a TTL field over there that is used to prevent the loop. And this loop will be finite time because we have a finite, right? 255 to 0. But if I talk about the layer 2 loop, right? If you have a look as well as, I'll make a trace dot 8.8.8.8.8, or I can use, some option was there, TTL, minimum I can define the 0 and maximum it will go to 255. See, you have to always look, also look up over there as well as, can you see the delay is increment 76 and this guy 120 like this? But this will be end, right? Once it will become the 0, this will be end. But in the case of layer 2, in the case of layer 2 network, if you have a look, I have a switch over there, right? I have another switch, and take example, we have one PC over there, and this is the another PC that's belong to the switch 2. And this is my trunk link, right? So this guy has an IP address will be, MAC will be, same thing, IP will be, MAC will be, sorry, IP2 and MAC will be switch 1, switch 2. This interface we have a 0/1. This interface we have a 0/1. This interface we have a 0/0, and this interface we have a 0/0. Understand one thing. Right now, if I say the ping, what happened? PC will look up the ARP table, right? Do I have an information on the one or two? No. So what happened? The first ICMP packet will be dropped. The first ICMP packet will drop, and then it will generate the ARP request packet, something like this. I'm not going to draw the ICMP request packet because you know everything, right? Already we have discussed lots of the time. So this is the ICMP request packet now. We have a source MAC, sorry, ARP packet, source MAC address, destination MAC address, source IP and destination IP. Source MAC address will be A, destination MAC will be FFF, source MAC will be A, destination MAC will be 000, source IP will be 101, and destination IP will be 102. R1 PC1 will send this packet to the switch one. What switch one will do? It will learn the MAC address 0/1. I'm going to learn the MAC address A, right? And it will forward the packet to whom? Switch 2. Switch 2 will learn this MAC address on the 0/0 A, and switch 2 will forward the packet to the PCB. PCB will receive this packet, and what they will do? This guy will get the reply packet, and the reply what happened? Sorry. Now the reply will be PC number 2. We have a source MAC will be B now. Destination MAC will be A. Source MAC will be B. Destination MAC A. Source I will be 102, and destination I will be 101. And it will give the reply packet to whom? Switch 2. Switch 2 will send this packet to the switch 1, and switch 1 will send the packet to the PC number 1. Right? But before sending the packet, all the MAC learning will process, like 0/1, I'm going to learn the MAC address B, and on the 0/0, I'm going to learn the MAC address A now. Sorry, B. And after that, we have all communication right now. All this communication, all the ICMP traffic. Whatever the traffic you are sending, all this traffic will go on. But take example, if this link goes down, then do I have a communication? No. If this link goes down, right? If this link goes down, do I have a communication? No. This concept is known as a single link failure. This concept is known as a single link failure. I don't have any backup link, man. Can you see that I just have a single link? If this link goes down, do I have a communication between this guy to this guy? No. Still, we are using the which concept? Wire media, right? Wire media means what? All the traffic has to follow the wire. Right? Wire means what? All the traffic has to follow the wire. Wireless means what? We need wireless communication means what? We need to follow the another medium. RF signal is a way. Wireless, what happened? We are using the RF signal to send the traffic. But in the wire, we need to use the cable. If this link goes down, do we have any connections over there? No. Single link failure is known as a. So to avoid this problem, what we came with the picture of multiple link. So we can say that this guy has a not 0/1, and this, sorry, 0/2, and this guy 0/2. Same concept. I will say the ping 102, right? First ICMP packet will drop, then it will get the ARP request packet, right? And the ARP request packet, what happened now? Now, once this packet is coming to the switch one will receive this packet. They will learn the source MAC address. That's the behavior of the 0/1 MAC address A, and it will forward the packet to whom? Now understand, this guy was on a switch to interface, right? On this particular interface, I'm going to learn the MAC address A, right? That's my behavior. And then this receive packet, what I'm going to do, I will forward the packet to this guy, and from this interface as well, right? Same way, I will receive this packet on this particular interface 0/2. Which MAC address I'm learning? A. I'll forward the packet to the home, this guy, and this guy as well as. Switch one will receive this packet on 0/0 interface, MAC address A. Again, switch, I will receive on same information on 0/2 as well as, right? Because this packet is also coming over there. This black one on 0/2, I'm going to learn A. So are you able to see what's happening over there on the layer 2 network? On the layer 2 network, we don't have a concept of TTL field. We don't have a TTL. So if you don't have a TTL, so this loop will be infinite. Guys, my concern is totally is try to clear the concept of what is loop. This loop will be infinite. Infinite means what? It's an endless loop. This packet will be keep moving, right? Keep moving. And what's happening over there? Wastage of resources, wastage of bandwidth, unstable MAC address. Unstable MAC address. See, is it possible the duplication MAC address? No, but now it's possible. Duplicate MAC address on a multiple interfaces, right? On a 0/1 same MAC address, 0/0 same MAC address, and 0/2 same MAC address. Over there, 0/0 same MAC address, 0/2 same MAC address. This is a loop. Learn the same MAC address on multiple interface or loop. Learning the same MAC address, right, on a multiple interface called as a loop. And this loop is happening. See this MAC address. And this loop will be infinite. It's endless because on the layer 2 network, we don't have a concept of the TTL. We don't have a concept of TTL on the layer 2 network. If you see one thing, take example, I'll take some PCs over there, switch as well as PC1, switch 1, switch 2. I'm going to connect the two cables over there because a single, otherwise single link failure will happen, right? Just provide the redundancy and backup our two links. Define the IP address of this guy. This guy. So IP will be 101, IP will be 102, right? And on this guy, I'm just going to do something right now. Forget this thing right now, this command. Just forget this command right now. I'm just trying to show you the loop right now. That's it. Then I'll come to the solution. Now, if I'm going to generate the packet, right? See, first ICMP packet from here to here. The packet will drop. Encapsulation failed, right? Remember the first packet will drop just because of the encapsulation failed. Then it will generate the RPQS packet. CR. Make it auto capture play. See the behavior. Two packets I'm receiving from the switch 1 and switch 2 will send the two packet. Switch 1 again send the packet. And this loop will be infinite. This loop will be infinite. Can you see that? Guys, before learning the technology, first need to find the problem. If you know the problem, you can easily explain any person, right? Almost 30 to 40 minutes, any topic. Because if you don't know the problem, then there's no need of solution, right? I have been seen that many people's, right, they know the solution. Yesterday what happened, if you know the problems, you can explain in the better way. And right now what's problem is happening, loop is happening. Why the first case in the loop was not happening the single cable? Because in the single cable there is no loop, right? But if you add the multiple cable, loop will be happen. But in the single cable, what is the problem is happening? Single link failure, right? In single what happened, we have single link failure. That's why we have put the another cable over there. You understand my concept, what I'm trying to say? That if I add the another cable loop, are you able to see that almost layer 3 loop about to be done, right? And can you see the delay is happening, the huge amount of delay keep increasing. Loop will impact on your CPU, and even if it's impacting on my laptop as well as right now. Maybe because sometimes making an impact. See, right now the packet tracer, right, is requiring the 6.6 CPU. Normally, it's not required the 86 MB memory. It will be never and never ever. And can you imagine if you have a 500 switches in your network, guys? If you have a 500 switches in your network, then your CPU will be high, right? Link will get congested, and maybe your device will get crashed. Not maybe, of course, yes. So to avoid this problem, maybe you have a question, hey Law, I can do one thing. I will put the one guy over there, and what this guy is going to do, I will put the one guy over there and one guy over there. I will shut down this link right now. Yeah, that's an amazing solution. This is the amazing solution. Shut down this link, right? So all my traffic will go by the this link, and there's no loop, right? And what this guy is going to do, he's keep monitor your, like, monitor your link. He's going to keep monitoring, right? He will put the keep eye on the link. Once this link goes down, take example, what happened? He has to up this interface. And once this link comes up, he has to down this interface. So everything you have to do manually, man. Everything you have to do manually. First shut down this interface, then traffic will go via this link. If this link goes down, traffic will go via this link. But you have to do everything manually. There's no dynamic way, right? That switch easily identify, okay, there is a loop. Let me put the one link as a down. There's no dynamic way. We have to do the static, right? Manually, you have to do that. So in the 90s, 84, right? In the 1984, this girl has introduced, right, the spanning tree protocol. In 1984, if you have a look, in 1984, this girl has introduced the Parliament invented the spanning tree protocol while working for the DAC. DAC was the one organization, right? They give lots of things in networking, lots of things. In 1984, they introduced the concept of spanning tree protocol. And what this guy is going to do, this guy is going to prevent the ray to loop. This guy prevent the ray to loop. So by default, right now, can you see the same packet is moving on? It will be endless, infinite. What spanning tree protocol is going to do, guys? And by default, this protocol is enabled on every switch port interface. Every interface doesn't matter, it's an access port or trunk port. On every interface, the spanning tree protocol is enabled. And what is the goal of this protocol? The goal of this protocol, prevent loop. It will put the port, not one port. It will put the all remaining port into lock state. So only one interface you will have to forward your data traffic. For example, the meaning of this line is saying that if you have a switch one and switch two, if you have four links over there, right? Or three links as well as. So this link will be blocked. Only one link will be there to forward the traffic to prevent the loop, because now spanning tree will be present on this guy and this guy. It's going to prevent the loop. And you don't need to do anything, right? It's automatically done dynamically. For example, somehow if this link goes down, take example, somehow if this link goes down, any one of the link, right? Any one of the link will be up. It will not impact all your data traffic. For a few seconds, it will impact, but it comes automatically. You don't need to do anything. But at the end of the day, you have a single link. Doesn't matter if you have a eight ports of the link, all the seven port will go in the block state. How many ports we have? Only one. They all behave like a backup. They all behave like a backup. And at the end of the day, you will have only one port to send and receive the traffic. All done. So right now, that's why I disable the spanning tree protocol. If you go and enable the spanning tree protocol right now, I've disabled it. By default, it's enabled. And now it prevents the loop. Go on. Now, if you see one of the port, right? Wait for some time. See, one of the port is moving the blocking state. Orange, can you see the orange one? Block. Now spank is enabled. They prevent the loop. Now if you send the packet, capture, forward, this guy, reply. How many reply I'm receiving? And now I simply comes in the picture. You can see this line. Somehow, if the one of the primary link this goes down, take example, I'm just going to shut down this link. Let me see which interface is blocking state. Come on, first country. Okay, just to and see which one is the blocking country. My blocking is 0/2. I'll do one thing. I'll just going to shut down the 0/1. If I want to shut down this link, right, 0/1, right? If this link goes down, this link, right, comes in the backup. It will be appeared as a primary. See, this link is not working, right? So this will appear as a primary. Did I do anything? No. Automatically, or spanning tree is doing. So the behavior of the spanning tree protocol, guys, the behavior of the spanning tree protocol, it prevents the layer 2 loop. If you don't have a spanning tree protocol in your network, man, it's never ever recommendation to disable the spanning tree loop. Never ever recommendation. It's never recommendation to disable the spanning tree protocol. Never ever. If you're disabling, you are inviting the loop in your network, because ARP always will be there, right? ARP always will be there. This is how your spanning tree protocol is going to be work, guys. The whole concept, right? At the end of the day, this class will be over the 4 days and 5 days of the class will happen on the spanning tree protocol. We are, yes, at the end of the day, you will only understand one thing, that one port will go in the blocking state. Not one. If you have 8 ports, 7 port will go in the blocking state. If you have 2 ports, 1 port will go in the blocking state. You will have at the end of the day, right? You will have only single path. How the loop remains is banging, and everyone has a different. Spanking protocol has a different flavors, right? So this guy has a flavor like, if I talk about the flavor, this guy has a flavor Spanking protocol. We have a CST, we have a PVST, we have a RSTP, and we have MSTP. CST, we have PVST, and we have a RSTP, and we have a MSTP. All this protocol we have. So these are the just a flavor of the Spanking protocol, right? In Cisco term, this is called as a, sorry, PVST, and we have a PVST plus as well as, right? I'll let you know what is the difference between this PVST and PVST plus, and we have a rapid PVST as well as RPVST. This 2 one is also there. I'll let you know what is the use of this one. But working is same, nothing is different. I'll let you know the difference, not a big difference. but these are the flavors, right? So to understand the CST protocol, sorry, to understand the MST protocol, you first need to understand the RSTP. And to understand the RSTP protocol, you need to understand the PVST. And to understand the PVST protocol, you need to understand the CST. So the flow will be like this. The flow will be like this. If I talk about it in a very simple way, right, what is the main difference with this guy? CST, no load balancing. Simple language. In a very simple way, you cannot do the load balancing. You do have ability to do the load balancing on a late unit. This is slow, but this is fast. And in MST protocol, what happened? It is fast, but I can improve the performance. That's why you're going to use the MSTP. So all have a reasons, right? Why do we need and which one I'm going to use for the company? It's not like okay, you can go for the MSTP because this is everything is good over there. No, it's not like that. Depend on the company requirement you have to use, and you will get to know that what's the requirement of your company and how you will how you will select whatever the selection criteria to select any protocol. There's lots of matching criteria that to select any protocol to run in the production. Okay, it's not अच्छा मैं जाके बोलूंगा अच्छा मुझे है ना ये HRP चलाना ले ले चला ले. It's not like that. You have to match the lots of criteria, and that is a that's called as an architect guy, right? The design person. Why they are charging the lots of money? Because they have a huge knowledge, right, about the depth level of the packet level. Right? They know each and everything. They know which will impact on the CPU, which not. So guys, our agenda is starting from the here, CST to the PVST, then PVST to RSTP, and RSTP to the MSTP. Or in between, we have a something called as a spanning tree protection. How we can secure, right, our spanning tree topology. How we can secure our spanning tree topology over there. So these are by our agenda. So these are the topics that we are going to cover in this 90 protocol. So tomorrow we are going to start from the this way. CST, it will take the complete 1 days and 2 days. So 2 days we have a complete discussion on the CST protocol because lots of things are there. The spanning tree states, packets, and many more things are there, right? And then it will take the 1 day for the this guy, 1 day for the this guy, right? And 1 day for this guy, and 1 day for this guy. Almost 5 days minimum it will take the classes for the all spanning tree protocol. But the complete of this figure, right? Prevent layer to loop. But the deployment and which one we are going to use, it's a totally different. Each one is different from another one, but concept is same, result is same. Normally in the production, it's recommendation to use the this one and this one, right? Because it's a very slow. I'll let you know why this thing is happening, why this protocol is very slow. You can ask questions, guys. Anyone has a question in the VLAN part? And what is the difference between the layer 2 loop and layer 3 loop? Now, hope this concept is also clear to all of you guys. What is the use of TTL fit? Because person has completed your CCNP. They complete the CCNP, but they don't know what is TTL. So if you go and ask, hey, tell me what is TTL? I heard this word first time, right? Guys, questions? Anyone has any questions, guys?
No, as you said, we use VLAN.1 to tag native, right? Or for preventing loops.
Mm-hmm. Dot, no, not preventing loops. This is
Yeah,
a totally different topic.
prevent attack.
Yeah, it's a prevent the attack. Dot one queue.
So what if user tries till he reach the target? See if so, as you said, we
It will not reach the target because this tag will be still built there right now, right? And this tag will be still there. So once the switch will receive the packet, what will do over there? It will send the packet in the VLAN number 10, right? Not the 20.
okay,
Understood?
yeah.
Any other questions? Anyone? No. तो एक काम करना,
No.
एक टास्क पता कर ना. Right now we are using the Ethernet technology, right? What is the disadvantage of Ethernet technology? पता कर इसको. You can also put the message in the chat as well as like WhatsApp group. If you get the answer right now, you will put it in the message. So can you see that this loop has ended? 255 hops. It's a finite, right? All done, guys. So I'm done. See you tomorrow with the spanning tree protocol. I'll tell you one thing: the spanning protocol has a lots of theory, so you need to have a good patience, right? Understand the theory parts, very important. Otherwise, at the end of the day, what happened? They are going to prevent the loop. All done, guys. Have a great night. Bye bye. See you tomorrow.
Hello. Thank you. Good night.
Thank you, guys. Port is up even when other end no configuration. I didn't get your Ganesh question. I didn't get your question.
Ethernet disadvantages.
Okay, Ethernet disadvantage port is even up when the other end no configuration. Okay. Any other?
Sir, if it is application is application traffic is more means it will not properly, sir, in internet technology.
Okay, I'll say take your time. I'll let you know this one. Okay, don't worry. Take your time and find the good one, right? Then I'll let you know.
Okay.
Bye bye.